Where is the best place to search for life beyond the solar system? Astronomers using telescopes at ESO's observatories in Chile have discovered 3 planets around a dim dwarf star, just 40 light-years from Earth. These worlds have sizes and temperatures similar to those of Venus and the Earth. They may be the best targets so far found in the hunt for life elsewhere in the universe. This is the ESOcast. Cutting-edge science and life behind the scenes at ESO, the European Southern Observatory. New telescopes and more sophisticated instruments have allowed astronomers to discover and study large numbers of planets around other stars, known as exoplanets. Now scientists are searching for planets where we could detect life in the near future, if it exists. Astronomers hope to find the characteristic signatures in the atmospheres of these planets of molecules that could indicate the presence of life. But there are billions of stars in our galaxy, so how can they find the kind of planets they're looking for? A type of tiny dim red star called an ultracool dwarf is a good place to look. They are the only places where life could be detected on an Earth-sized exoplanet using our current technology. The light from much brighter stars, like the Sun for example, would swamp vital measurements of the atmospheres of any candidate planets. An international team of astronomers has used the Belgium TRAPPIST telescope to monitor the brightness of an ultra-cool dwarf star in the constellation of Aquarius, which has been named TRAPPIST-1. They found that it faded slightly at regular intervals, indicating that 3 planets were passing between the star and the Earth, events known as transits. The host star TRAPPIST-1 is much cooler and redder than the Sun and barely larger than Jupiter. Stars like this are very common in the Milky Way, and they are very long-lived. This is the first time that planets have been found around one of them. Transits like these provide a surprising amount of information about the planet. The team were able to tell that the 3 planets are very similar in size to the Earth and that they orbit very close to their dim parent star. But the really exciting result is that all 3 planets might have habitable regions on their surfaces. This study has found the first Earth-like planets that are well suited for the detection of biological activity. The next step is to make more detailed observations using the next generation of telescopes, such as ESO's European Extremely Large Telescope and the James Webb Space Telescope, scheduled for launch in 2018. That will allow astronomers to study the atmospheres of planets like this and to search for molecules related to biological activity, like ozone, methane, or water. Ultra-cool dwarf stars are common. They account for around 15% of the stars near to the Sun. So this discovery opens up a new direction for planet hunting. A direction that is taking us one step closer to the goal of finding evidence for some kind of life on distant worlds. 25 years ago, not a single planet outside the solar system had been detected. But remarkably, we now know of thousands, and have studied many in surprising detail. ESO's observatories in Chile have been at the forefront of this enormous expansion in knowledge, and their state-of-the-art instruments are continuing to discover and study the extraordinary diversity of exoplanets. This is the ESOcast. Cutting-edge science and life behind the scenes at ESO, the European Southern Observatory. Looking up at the night sky, people throughout history have wondered if there are planets, and especially planets bearing life, beyond the solar system. Astronomers have also asked themselves these questions and many more. Are planets common or very rare? Do they resemble planets in the solar system, or are they totally different? Frustratingly, until very recently, observational techniques were not advanced enough to be able to answer any of these questions. But in 1995, this changed overnight. The first exoplanet orbiting a Sun-like star was detected. The monumental discovery was made by Geneva-based astronomers Michel Mayor and Didier Queloz around the star 51 Pegasi. The exoplanet named 51 Pegasi b has around half the mass of Jupiter and travels around its parent star in just over 4 Earth days. But this was only the beginning. The initial trickle of discoveries became a flood. Thousands of exoplanets have since been detected in a huge variety of sizes and orbits. Many of these discoveries have been made by ESO's observatories in Chile. But the hunt for exoplanets is a challenging one. These alien worlds hide in the shadows, giving off little or no light of their own. Any light that they do emit is swamped by the overwhelming brilliance of their parent star. However, advanced observational methods can be used to spot these elusive exoplanets. The weak gravitational pull of an exoplanet in orbit causes its parent star to wobble back and forth. This tiny motion causes a small shift in the star's spectrum, which extremely sensitive spectrographs, such as ESO's HARPS, can detect through radial velocity tracking. HARPS, installed on the ESO 3.6-meter telescope at the La Silla Observatory, is the world's foremost exoplanet hunter. It's the most successful finder of low-mass exoplanets to date. In 2010, the instrument discovered the richest planetary system yet. The system, located over 120 light-years away around the Sun-like star HD 10180, contains at least 5 exoplanets. There is also tantalizing evidence that 2 more planets may be present in this system, one of which would have the lowest mass ever found. Planetary transits can also be utilized by astronomers to indirectly detect distant worlds. When an exoplanet passes in front of its parent star, as seen from the Earth, it blocks a small fraction of the star's light from our view. This creates a dip in the brightness of the star, which can be measured. In addition to determining the size of an exoplanet, planetary transits can reveal the composition of an exoplanet's atmosphere. The atmosphere around a super-Earth exoplanet was analysed for the first time by astronomers using the Very Large Telescope. The planet, which is known as GJ 1214b, was studied as it passed in front of its parent star, and starlight passed through the planet's atmosphere. This starlight revealed that the planet's atmosphere is either mostly water in the form of steam, or is dominated by thick clouds or hazes. Directly observing an exoplanet is a monumental feat, but one that was first achieved by ESO. The Very Large Telescope obtained the first ever image of a planet outside the solar system. 2M1207b is 5 times more massive than Jupiter. It orbits a failed star, a brown dwarf, at a distance 55 times larger than the Earth to the Sun. ESO's telescopes are equipped with state-of-the-art instruments, but to remain at the forefront of exoplanet research, ESO has recently commissioned 2 new instruments for the VLT. Sphere is able to find and study faint planets masked by the glare of their host stars. And in the near future, the espresso spectrograph will arrive at the VLT, where it will surpass HARPS. The European Extremely Large Telescope, which is currently under construction in Chile, will take the hunt for exoplanets even further. Once operational, this 39-metre telescope could detect Earth-like planets and possibly evidence of alien biospheres. The search for planets outside the solar system constitutes a key element of what is possibly the greatest question of all. Is there life elsewhere in the universe? Over the past 20 years, our knowledge of exoplanets has advanced dramatically. But the quest for Earth-like planets and those that harbour life remains one of the great frontiers of astronomy. Are we alone? We do not know, but the answer is almost within reach. In early 2016, a select group of photographers visited ESO's observatories in Chile. Their mission: to obtain stunning visuals at these remote facilities for use in the upcoming ESO Supernova Planetarium and Visitor Center. This is the ESOcast, cutting-edge science and life behind the scenes at ESO, the European Southern Observatory. ESO's Supernova Planetarium and Visitor Center will open in 2017 at ESO's headquarters in Garching, Germany. It will share a wealth of breathtaking visuals with the public. The planetarium features a dome where fisheye images will be projected. Such extremely wide-angle pictures can be captured using specialist lenses attached to digital SLR cameras. What could be a better place to gather these unusual views of the pristine night sky than the Atacama Desert of northern Chile? In March 2016, the Full Dome expedition set off for ESO's observatories in Chile, where the very clear and dark night sky offers a perfect view of the heavens. The expedition team included renowned ESO photo ambassadors Yuri Beletsky, Petra Horaulek, and Babak Tefrishi. It was also strengthened by Theophanis Matsopoulos, a pioneer of ultra-fast planetarium cinematography. The team gathered first at Paranal, the home of ESO's Very Large Telescope. After capturing a collection of stunning visuals, the team prepared for the 6-hour journey to the largest ground-based astronomical project in existence, ALMA, the Atacama Large Millimeter Submillimeter Array. Here, 5,000 meters above sea level in the challenging conditions of the Chaknantor Plateau, the team worked hard to capture more dramatic material. Chaknantor may be perfect for submillimeter astronomy, but the low oxygen air and cold, dry conditions make working conditions extremely demanding for humans. After the grueling effort of long, cold nights imaging at ALMA, our team turned southwards and travelled to the last stop on their journey, La Silla, ESO's first observatory. La Silla has long been an ESO stronghold, and the organisation still operates two of the most productive 4-metre class telescopes in the world from the site. The tried and tested infrastructure of La Silla is also used by many of the ESO member states who run projects at their own facilities. With such a wealth of material to image, the team spent some time exploring the observatory and choosing the most promising sites. As at Paranal and ALMA, the material produced by the Full Dome expedition at La Silla is mesmerizing. ESO's Full Dome expedition has successfully captured a very wide variety of beautiful visual material, including full dome time-lapses, stills and thousands of images of ESO facilities and the superb Chilean night sky. And for our hard-working team of astrophotographers, the trip was a perfect opportunity to test and develop their skills under some of the darkest skies on Earth. The pristine Chilean skies did not disappoint them. The ESO Supernova will be the first open-source planetarium in the world. As such, ESO is offering all of these high-quality visuals for audiences from the public to fellow planetariums for free. You can already download the first results from ESO's website. The Full Dome expedition has opened a new way to bring the beauty of Chile's skies to the public. It continues ESO's mission to share the wonders of the night sky with all who care to view them.
Astronomers using ESO's leading exoplanet hunter, HARPS, have today announced more than 50 newly discovered planets around other stars. Among these are many rocky planets not much heavier than the Earth. One of them in particular orbits within the habitable zone around its star. This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory. In this episode of the ESOcast, we take a close look at another major exoplanet discovery from ESO's La Silla Observatory, made thanks to its world-beating planet hunting machine, HARPS. Among the new planets just announced by scientists, 16 are super-Earths, rocky planets up to 10 times as massive as Earth. This is the largest number of such planets ever announced at one time. A planet in orbit causes its star to regularly move backwards and forwards as seen from Earth. This creates a tiny shift of the star's spectrum that can be measured with an extremely sensitive spectrograph such as HARPS. In their quest to find a rocky planet that could harbour life, astronomers are now pushing HARPS even further. They have selected 10 well-studied nearby stars similar to our Sun. Earlier observations showed that these were ideal stars to examine for even less massive planets. After 2 years of work, the team has found 5 light super-Earths around 3 of the stars. These planets are very good candidates for future observations looking for evidence of life. One of the newly found planets, named HD 85512b, orbits inside the habitable zone. This is the narrow area around a star where water can exist in liquid form. Astronomers estimate that liquid water could possibly be present on this planet if it is a rocky world that has more than 50% cloud cover. By looking carefully at the results from the first 8 years of HARPS observations, the team has found that around 40% of stars similar to the Sun harbour at least one planet lighter than Saturn. These new results lead astronomers to believe that they could soon find more super-Earths in the habitable zones of their stars with HARPS. These planets will be great targets for powerful future telescopes to try to study their atmospheres, looking for evidence of life. Thanks to HARPS, the search for another Earth elsewhere in the galaxy is picking up pace.